So our goal for today is I can find the area of a regular polygon. So first off, let's talk about what a regular polygon is. So a polygon, not a regular polygon, is any closed shape with 3 or more sides. A regular polygon means that all of the sides are equal and all of the angles are equal. So we've seen regular polygons before. We've seen a regular triangle. What's a triangle that has all sides congruent and all angles congruent? An equilateral triangle. So it has a special name. But a hexagon, there is no special name for a hexagon with all congruent sides and all congruent angles, so we just call it a regular hexagon. This figure, the first figure right here, that's technically a hexagon. It has 6 sides, but it's not what you'd think of when I say picture a hexagon. This here is a regular hexagon where all the sides and all the angles are equal, and this is most likely what you have in your mind anyways. Okay, so now we need to go over vocab. So the center of a regular polygon is equidistant from the vertices. So the center is exactly where you think it is. This is the center right here of this hexagon. That distance to each of the vertices is called the... I'm not going to fill it in. I probably can have you guys think of it. So think about connecting all of these. Ooh, this is not going to look that pretty. Think of connecting all of those points right there. I'm talking about this distance from the center to a vertex. What do we think that's called? Picture the circle. If you guessed radius, you guessed correctly. That's a radius. So the distance from the center to any vertex, this is a radius. Okay, we also have another piece, another distance right here. This is the distance from the center to any midpoint of one of the sides. So this distance right here, and notice I said it was the midpoint, so it breaks it into 2 congruent pieces here. That is called the apothem. Now people sometimes pronounce it apothem. I pronounce it apothem, like an app that you would have on your iPad, othem. So this right here is your apothem. Okay, so next vocabulary word is a central angle. A central angle of a regular polygon has its vertex at the center, and its side passes through the consecutive vertices. Each central angle has a measure of 360 divided by n. Okay, so what that's talking about, I'll look at this and I'll end up erasing it here. If I said that this was a regular polygon, all the sides there are the same and all the angles there are the same, and I asked you, what's the measure of this angle right here? You could figure it out because you know how many degrees this whole thing is, right? This whole thing is 360 degrees. Now, for this particular one, I can divide that by the number of angles this is broken up into. So if I kept going like this, you can see that it's broken up to 6 congruent angles. So each of these angles right here, so let me change my color so you can see what I'm talking about. This angle right here is 60 degrees. Now we're not going to ever need that angle. We are going to need, let me highlight it in blue right here, this angle right here. But you can clearly figure out what that is there. It's half of 60 degrees. So I would have to take that answer and divide by 2. So when we're looking for that angle, let's just write our generic formula here. Instead of saying 360 divided by 6, take that answer and divide by 2. First off, let's get rid of that 60. And I also want to get rid of this 6 right here because not every regular polygon has 6 sides. So what we're going to replace there instead is put n. So you're going to do 360 divided by the number of sides divided by 2, and that's going to give you this angle right here. So once again, that's 360 divided by the number of sides divided by 2. Okay, now let's move on to the formula. Once again, if we were in class, I would derive the formula, show you where it's coming from. But since we're not in class and we want to make this a little bit easier for you, I'm just going to tell you what the formula is. It is area equals 1/2 of the apothem times the perimeter. So it's 1/2 times apothem times perimeter. You don't need these dots right here, but I want to make sure you realize it's multiplication. So remember what the perimeter is. The perimeter is the number of sides times each side length. Or sorry, not each side length, the side length. Now, the reason I say that is if this has 6 sides and all the sides are 5 inches, then the perimeter is 30 inches, right? That makes sense? So this only works if it's a regular polygon. Otherwise, you'd be adding up all your sides. Apothem is right here, A. Okay, so really quickly pause the video, see if you can fill this out. Let's review how you name a polygon by the number of sides. So what do you call a 3-sided figure? 4-sided figure. Go ahead, pause the video, try to fill in as many as you can, and then we'll go through them and make sure you got them correctly. You got them correct, not correctly. Okay, so you should have gotten that a 3-sided figure is called a triangle. A 4-sided figure, I'm assuming that a few of you put square or rectangle or parallelogram, but even those are being too specific. The word for 4 is quad, so this is quadrilateral. 5 sides, pentagon. 6 sides, we already talked about today, hexagon. 7 sides. Now 7 sides I've seen called septagon and heptagon. We use heptagon. 8, octagon. 9 is non-agon. 10 is decagon. 11 has a name if you Google it, but we don't use that name, so we call it an 11gon. Now that's for anything higher than 11 except for 12. 12 is a dodecagon. But anything higher, so like something with 13 sides would be a 13gon. Something with 14 sides would be a 14gon. So whatever number it is, dashgon. Okay, so we're ready to try our first example. If you look here, we have, I don't know why the goal is right here. It should be at the end of the lesson, but it looks like a little mistake I made. No big deal. So we have 4 examples, and then after that, it is a you try all at the end, and then also just a review of figures that we've already done before. Okay? All right, so let's get started with the first one here. Find the area of the regular hexagon. So it says regular hexagon, so I'm going to write down my formula. Area equals 1/2 apothem times perimeter. It tells me that the side length is 10 feet. So I know each side is 10 feet. I can put that here. I can put it at the bottom. I can put it on any side that I want. Round to the nearest tenth. So find the area, round to the nearest tenth. Okay, so I'm going to say area equals 1/2. Did I give you the length of the apothem? Absolutely not. It doesn't say the apothem is. It's not in the picture. So what I'm going to do is I'm going to leave a space. I'm going to leave a pretty big space because what you're going to see is that it's not going to be a nice answer usually, and we're going to have to use either SOHCAHTOA or special right triangles to get it. And then I have my perimeter. So did I give you your perimeter? Well, I gave you that. All of your sides are 10, and there's 6 sides. So technically, I did give you your perimeter. Your perimeter is 60. It comes from 6 times 10. So 60 feet. So that is not an unknown. Okay, the only unknown right now is my apothem. So what I need to do is I need to find it. So what I'm going to do is I'm going to draw my apothem in my hexagon. So there's apothem A. That's what I'm looking for. I'm going to put a little right angle right here, and then I'm going to always drop a radius to make a right triangle. Okay, so now that I'm going to say, what do I know? Did I give you the radius? Nope. Did I give you this piece? I sure did. Remember, an apothem cuts this into 2 congruent pieces. So I'm actually going to erase that 10 feet right there, and I'm going to put 5 feet right here. Okay, so the other thing that I can always find this angle using the formula 360 divided by the number of sides, which in this case is 6, and then divide that answer by 2. So 360 divided by 6 is 60. 60 divided by 2 is 30 degrees. So I know this angle, and it's going to erase my whole thing, isn't it? Yeah. Just right over it. Oh, I'll just write over it, is 30 degrees. Okay, so now I need to solve for A. Can't use Pythagorean theorem because I only have 2 sides, but I can use SOHCAHTOA, or I can use special right triangles because I know this is 60 degrees right here. I think most people will end up using SOHCAHTOA on this one. And if you're like, I'm using special right triangles, then I'll tell you what your answer is for that in just a moment. So I'm going to go with SOHCAHTOA. So here's my angle, opposite and adjacent. So I'm using tangent. Tangent of 30 degrees is equal to opposite, which is 5, over adjacent, which is A. Cross multiply to solve for A. We have A times the tangent of 30 is equal to 5, and then go ahead and get A by itself by dividing both sides by tangent of 30. So now we know the apothem is 5 divided by tangent of 30. That's why I left this big space here, because we're going to leave it as 5 divided by tangent of 30 and then pop it in our calculator as one big problem. Okay, I'm ready to type this in my calculator. So how I would type it is I would type 0.5, parentheses 60, close the parentheses. I just like typing that first. Then I would do parentheses 5 divided by tangent 30, close the parentheses. Hit enter. You should be practicing this in your calculator, so if you don't have your calculator, go ahead and pause the video and then go get your calculator and try it out. Okay, so it says round to the nearest tenth. So you should have the answer of 259.8 feet squared. All right, really quickly, if you said that's a 30, 60, 90 triangle, across from 30 is 5, so across from 60 is 5 root 3. If you have 5 root 3 here instead and you put this in your calculator, you're going to get the exact same answer. So either way is fine with me, but remember that only works on 30, 60, 90, and 45, 45, 90 triangles. All right, next one. Find the area of the regular octagon with apothem of 12 centimeters. Round to the nearest tenth. So once again, I'm going to write down my formula. Area equals 1/2 apothem times perimeter. Area equals 1/2. Did I give you the apothem? Yep, this time it's 12. Didn't give you the perimeter though. So I'm going to leave a big space for it because once again, it's not going to be the prettiest answer when I'm writing that in there. Okay, so now what we're going to do is we're going to draw this into our figure because we always are going to have to use a picture to help us figure out whatever we're missing. Put the center. Drop your apothem. Your apothem, I'm not labeling A. I gave you it's 12 this time. I'm going to draw my radius. I'll find this angle because I can always find that. 360 divided by, this is an octagon. It has 8 sides, and then divide that answer by 2. So I'm going to do 360 divided by 8 in my calculator. I get 45, and then I'll hit divided by 2, and I get 22.5 degrees. So I know this angle right here is 22.5 degrees. Okay, now remember, I'm finding the perimeter. So let's think about this. I'm going to be able to find this piece. I'll call it X. Everyone agree I can use SOHCAHTOA to find that piece? Is that my perimeter? So think about what you're going to have to do to get the perimeter once you have that answer. Let's say I get this answer is 2, which it's not, but let's just say I get that as an answer. What's your perimeter? How would you get it? Well, I can get this side by doubling 2, and then I can get the perimeter by multiplying it by 8. So we have to remember to do that once we get X. Okay, let's go ahead and solve for X. Here's my angle. This is opposite. This is adjacent. So we have tangent, once again, of 22.5 is equal to opposite, which is X, over adjacent, which is 12. Put tangent over 1 and cross multiply. You get X equals 12 times the tangent of 22.5. So that is, once again as a reminder, this piece right here. How do I get the length of one side? I would have to multiply this by 2. So that is one side, all right. If I multiply this times 2, all I have to do is double 12. So that's 24 tangent of 22.5. All right, well, now that I have the one side, how do I get the perimeter? Well, there's 8 sides, so now I have to multiply my answer by 8. So now I'm going to multiply this answer by 8. So the perimeter is going to be 8 times, I don't need that parentheses there, I don't know why I put it, 8 times 24 tangent of 22.5. Now, you could see what 8 times 24 is right now and change that number right there in front of the 22.5. The 22.5 is not changing, okay? But I'm just going to leave it because I don't know what it is off the top of my head. All right, so I'm going to put that right here. 8 times 24 tangent of 22.5. All right, so now I have to put this in my calculator. So in my calculator, I'm going to do 0.5, parentheses 12, close parentheses. Open a new parentheses, 8. Open another new parentheses. 24 tan 22.5, close parentheses, enter. Area equals 477.2 centimeters squared. All right, so far we've seen a problem where you had to find the apothem to get the answer. You had to find the perimeter to get the answer. And now we're going to do another one where you have to find the apothem to get the answer. Okay, so if you want to pause the video and try this one yourself, by all means do so. If you need to see me do it again, then let's see me do it again here. Area equals 1/2 apothem times perimeter. Area equals 1/2. Did I give you the apothem? Find the area of the regular octagon with perimeter of 96. No, I did not, so I'm going to leave a big old space for it. But I did tell you the perimeter is 96. Okay, I need to find the apothem, so I'm going to go ahead and draw that apothem in. I don't know it. All right, next, this angle right here. 360 divided by the number of sides. This has 8 sides once again. And then divide that by 2. We already did that math. That's 22.5. Okay, so now I have to say, what else do I know? Because I have to know something else if this is what I'm looking for. Well, I know this piece. I know the whole perimeter is 96. So I can figure out the measure of each side by dividing it by 8. Whatever I get as an answer for that, which is 12, then I can divide that by 2 because I need to break it into 2 pieces. So I know that this whole thing is 12. So half of that is 6. Now I can use SOHCAHTOA to find the apothem. This is opposite, this is adjacent, so I'm using tangent. Tangent of 22.5 is equal to opposite, which is 6, over adjacent, which is A. Cross multiply. A times tangent of 22.5 is equal to 6. Divide by tangent of 22.5. That's going to give me A, which is what I was looking for. So I can go ahead and here put 6 divided by tangent of 22.5. Go ahead and pause the video and try typing that in your calculator. Once again, I would have done 0.5, parentheses, 96, close the parentheses, open a new one, 6 divided by tan 22.5, close the parentheses. If you typed it correctly, you will have 695.3 centimeters squared. All right, our very last problem that is new. The rest is all review. It says find the area of the regular hexagon. So area equals 1/2 apothem times perimeter. 1/2. Did I give you the apothem? So is this an apothem? No, that's a radius. So I didn't give you the apothem. Leave a big space for it. Did I give you the perimeter? No, I gave you the radius. So this one, you're going to have to find the apothem and the perimeter. This one is by far the most challenging because it has the most work, but at the same time, the math is a little bit easier. Okay, so let's start off by finding the apothem. So I'm going to go ahead and draw it in down here because I just like having it at the bottom. So I don't know what the apothem is. The radius, which is right here, I know is 8. And then I can find this angle right here. So 360 divided by 6 divided by 2. We already said we know what that is. That's 30 degrees. All right, so I'm going to find A, the apothem first. So here's my angle. This is adjacent, and this is hypotenuse. So cosine of 30 degrees is equal to adjacent, which is A, over hypotenuse, which is 8. Cross multiply, and I get A is 8 times the cosine of 30 degrees. So I have my apothem. Come over here. 8 times the cosine of 30 degrees. Right? Not bad. All right, now I need the perimeter. Okay, so remember, to get the perimeter, you are going to need to find this piece right here first. Okay, so I don't need this A anymore, so I'm going to cross it off so it doesn't confuse me. So now here's my angle. This is opposite. This is hypotenuse. So to find x, I'm going to use sine. Sine of 30 degrees is equal to opposite, which is x, over hypotenuse, which is 8. Cross multiply to solve for x. You get 8 sine of 30 degrees. Okay, now remember, you just found this piece and you need the perimeter. I didn't ask you to find x, I asked you to find the perimeter. So now I need to double that. So times 2 to get the side. That's 16 sine of 30. And then now I can get the perimeter by multiplying that answer by the number of sides, which is 6. So I have 6 times 16 sine of 30. All right, now I can go ahead and put that in my calculator. I would do 1/2 parentheses 8 cosine of 30. If a parentheses opened in front of your 30, remember you have to close it and then close this one. Open a new parentheses, 6, open a new parentheses, 16 sine of 30, close parentheses, close the parentheses. If you got 166.3 meters squared, then you typed it in correctly. Now I want to show you another way you could have done this one. You could have realized that, let me erase this X and A here. This is a 30, 60, 90 triangle. So I have across from the 90 degree angle is 8. So across from the 30 degree angle is 4. Across from 60 is 4 root 3. So you could have said that your apothem, so you could have done area equals 1/2. My apothem is 4 root 3 times my perimeter. So remember, my perimeter is not 4. I have to double that, which is 8. And then multiply it by 6, which is 48. If you put this in your calculator, you're going to get the exact same answer. So it does pay to recognize that as a 30, 60, 90 triangle. Okay, if you're good and you think you have it, then go ahead and try this last one. I'll tell you what the answer is. Go ahead and pause the video, and I'm just going to tell you what the answer is. And then I'll go back to do those other 2 problems. If you are good with, the trapezoid and the parallelogram, then you don't have to worry about these next 2 problems that I'm going to end up going over. Okay, so if you did this one correctly, you should have 1/2 apothem times perimeter. Area equals 1/2 of, I didn't give you the apothem. I gave you the side length was 4, and there were 5 sides, so I gave you the perimeter's 20. Draw on your apothem, that's A. To find this right here, I know the side length is 4, so this is 2. 360 divided by 5 divided by 2, that angle is 36. When you end up using SOHCAHTOA, you're going to use tangent, and you end up getting that this is 2 divided by tangent of 36. Popping that in your calculator, you get the area is 27.5 inches squared. All right, this one right here, find the area of the trapezoid. So area of a trapezoid formula, area equals 1/2 of base 1 plus base 2 times your height. Okay, so first off, I tried to pick one that was a little trickier where I didn't give you everything, but you can see that I gave you one of your bases and your height. So I can fill that in. Area equals 1/2 of, I gave you one of the bases, it doesn't matter which one, but I'll leave a space for the other one, and your height. So I have to figure out how to find this other base right here. Okay, so let's figure it out. Well, what I could do is I can break this into a rectangle and a triangle. Do I know how long this piece is? 8. Here's a right triangle. Can I figure out what this piece is? Do I know how long this piece is? This is 14 centimeters. Pythagorean theorem will let me figure out what this is. So if I do x squared plus 8 squared equals 10 squared, I end up getting 6 centimeters. So now you know that your second base is 20 centimeters. Pop that in your formula, and you get your area is 136 meters squared. All right, last one here, similar, but not exactly the same. Draw and label a triangle that would have the same area as the parallelogram. Well, it's not similar at all, I guess. Okay, so let's find the area of this parallelogram. Area is equal to base times height. Area is equal to 6 times 10. So I need a triangle with an area of 60 centimeters squared. So I'm going to draw a triangle. Remember, the formula for area of a triangle is 1/2 base times height. So I need to figure out two numbers that when I multiply them and then divide it by 2, I get 60, right? So I have to realize that these two numbers have to multiply to be 120 because half of 120 is 60. So any two numbers, 12 and 10. So I'm going to say my base is 12 centimeters, and then I'm drawing my height, 10 centimeters. So as long as these two numbers multiply to give you 120, your answer works. All right, I'll go ahead and get started on the homework.